Hi everyone, today we are going to be looking at a quick example application that was built using LangGraph and hosted on LangGraph Cloud. The example application we're going to be talking about today is a choose your own adventure style of story writing. The graph that you see in front of you is a graph of chapter nodes, so each one of these nodes represents a different version of a chapter. And they are chronologically sorted from left to right. So nodes 1 and 3 represent versions of chapter 1. The green nodes are versions of chapter 2. The yellow nodes are versions of chapter 3. And node 8, the blue node, is a version of chapter 4. And so in our application, the user gets to write the story alongside the LLM. So the LLM is going to do the writing for us, but the user is going to be able to choose to edit chapters, continue chapters, and build out this complex story graph so that they can write the best version of each chapter that they wish. And so today we'll dive into how we generate the graph that allows the user to have this interaction. We'll show how you can host that graph on LangGraph Cloud. And then lastly, we will look at the front-end implementation and interact with the app a little bit ourselves. Okay, so now let's walk through building the graph, and we're going to start off by setting up our imports. And as a reminder, if you want to see all of the source code, you can check out the GitHub repository in the description, because we're going to go through the code slightly quickly here. So if you want a detailed look, be sure to check out the repository. Okay, now that we have declared our imports, we can declare our LLMs. And in this case, we're going to define a bunch of different LLMs for different stages of our graph. And you can see our LLMs are labeled aptly. We've chosen a mixture of Anthropic and OpenAI models for this use case, but feel free to use whatever models you want when building your LangGraph graphs. That is one of the many benefits of using LangGraph, is that you have the freedom to choose whatever LLMs you want. So now that we've defined the LLMs for the different parts of our writing process, which we'll dive into a little bit later, let's look at the prompts that we're going to use to invoke these LLMs. Okay, we have a variety of different prompts that we are going to use to invoke our LLMs, and we'll just walk through them briefly. So our summary messages, which we're going to use for our summary LLM, is going to tell our LLM that it's focused on summarizing books. We're going to have a brainstorm LLM, which is going to brainstorm ideas for our chapter. And as you can see, we're going to pass in a couple of different pieces of information to this LLM, such as the summary request, the style request, and the story summary. And we'll go into all of this in when we discuss how we define our nodes. And then we have our outline messages and our write messages, which look fairly similar to the brainstorm messages. These are the three parts of the writing process that are going to occur every time. We're going to brainstorm, outline, and then actually write our chapter. Okay, so now that we've defined our prompts, let's finalize our chains, and then we can move on to defining the graph nodes. Okay, so our chains are going to be defined very simply. We're just going to be using the LangChain expression language, which if you're not familiar with, be sure to read up on the LangChain docs. And we're going to chain together our prompts, our LLMs, and then a simple output parser. And so now that we have our four chains ready to go, and we also have our two title LLMs from the top, which we are not going to use prompt engineering with because they have simpler tasks, we are ready to start defining our graph nodes. Okay, so first let's take a look at the helper functions that we're going to use for our graph. So we have three helper functions. One of them is going to be called summarize current story, which is going to summarize the story up to this point. And the reason we do this is because we want the LLM to be aware of what has gone on previously in the story. And so to do that, we're going to start from some chapter ID. We are going to recursively find its parent, which means traveling backwards in the graph. If you remember that diagram we first saw, we'll dive a little deeper into what parent means, but basically it's just the chapter that precedes it. And then once we've gone all the way back to the first chapter, once the chapter parent is equal to -1, that means we've reached the first chapter. We're going to stop. We're going to join all those together in a string, and then we'll use the summary chain to find the summary of the story up to that point. And then we're going to have our actual write chapter function. And like I mentioned, this is going to brainstorm ideas, outline the chapter, and then write a response. And that's going to use all of those chains that we described above. As you can see, we have some user message that we're going to pass in depending on the user's input, whether they want to edit a chapter, continue the story, or whether we're at the first chapter. And then we're going to pass all of that through these chains. And you can notice we're also going to take these brainstorm ideas and pass it to the outline chain right here. And similarly, we're going to take the outline and we're going to pass that to the writing chain. So these steps follow each other sequentially and hopefully help the LLMs write a more convincing and logical story. And then at the very end, we're going to use the chapter title LLM to come up with the title for the chapter. And then we'll return those two things. And then the last helper function, which we're only going to use once, is the get title helper function, which just comes up with a title for the entire story. So we only call this once at the beginning, and we are going to keep the same title throughout the entire story. So now that we've defined our helper functions, let's look at the definition of our three nodes: write first chapter, edit chapter, and write next chapter. So let's start with write first chapter. So write first chapter is a fairly simple function. What it's going to do is take in these three user requests: summary, detail, and style, and it's going to turn those into prompts if they exist. So the user doesn't need to input all three of these. But at the beginning, when deciding to write a story, we're going to let the user enter an overall summary, any details they want to be included in the story, and then a writing style that they would like for the story. So you can see we turn these into prompts if they exist, and then we're going to write a chapter using that write chapter function. And so in the summary parameter for the write chapter function, we're going to manually pass it in this time because there's no summary. This is the first chapter. And then our request is going to be to please write the first chapter of this story. And then we're going to update some of our state variables. We'll go into exactly what all of these mean, but basically we're just creating our initial chapter graph. So that diagram we showed at the beginning is the main part of our state, that chapter graph. And then we are also going to call the get title function. This is the only time we're going to call the get title function to generate a title for our overall story. And then we'll set the chapter ID that we're viewing and the current chapter ID both to this first node that we've created. We will explain the difference between chapter ID viewing and current chapter ID in 1 second when we go over the graph state. But for now, let's look at how we define the edit node. Okay, so the edit node is fairly simple. First, we're just going to define a edit prompt, which tells the LLM the current state of the chapter and then the edits that the user wants to make to that chapter. And so we take that prompt, we format it into this variable called user message, and then we're going to pass that to the write chapter function along with the chapter summary that we generated by calling summarize current story, which was that helper function that we defined earlier. And then we're going to have our content and our title, and then we're going to update our chapter graph. So we have to do a few things in there. So the first thing we're going to have to do is we're going to have to create our new chapter, which we do here with this new chapter object. And we have a variety of parameters for our chapter object. The important ones are these children, sibling, cousins, and parent variables, which are the relationships that this chapter node will have with the other nodes on the graph. We're going to dive into explaining all 4 of those in a second when we go to the graph state, And then we're going to have to do some more updates to the graph. And then at the end, we will just update the current chapter ID and the chapter ID viewing. Whenever we write a new chapter, we're going to set this chapter ID viewing to the current chapter ID because we're going to change the user's viewing to the chapter they just wrote. So when you write a chapter, the UI is going to automatically update that you're going to be viewing that chapter. And now let's look at how we write the next chapter node. So this is the next chapter node. It's fairly similar to the edit node. Again, we're going to have a prompt, and then we're going to summarize the story, format the prompt, and then write the chapter using that formatted prompt and the story summary up to now. And then again, we're going to update the state. Mainly, we're going to be updating the chapter graph by adding this new chapter to the chapter graph, adding the chapter we just wrote, and then we're going to update the relationships of the chapters that the relationships need to be updated. So now that we've written this new chapter, there are some chapters, some of the old chapters from the graph need to add this chapter as a cousin, and we'll explain what that means in 1 second. And then at the end, again, we'll change the chapter ID and the chapter ID viewing to match this current chapter. All right, now that we have finished defining our nodes, we can define our graph state and then actually compile the graph. Okay, so we have two classes in our state. The first one is just the chapter class, which just represents a single chapter. And it's fairly straightforward what these are. And then we have our overall state, which contains a little bit more information. So these style, summary, and details attributes, as we saw, are used in the write first chapter node, and then we don't edit or change these after that. So these are just requests that the user can make when they initially click on writing the story. And then we have this chapter graph, which is the graph that actually contains all of the information. So chapter graph, it basically just means a dictionary with all of the chapters that we've written so far, and then it contains information about the relationship between those different chapters. So we're going to dive into that in just 1 second after we explain these last few parameters. So we have this chapter ID viewing and this current chapter ID. So chapter ID viewing is pretty straightforward. It's what node in the graph the user is currently viewing. So when we see our front end, you'll see that the user has the ability to move around the graph really easily and view different chapters and read whatever chapters they want. So we need to make sure we know where the user is at any point in time, so that when they click edit or when they click continue, we are actually editing the right chapter, or we're actually continuing from the right chapter. And then the current chapter ID just means how many nodes do we have up to this point, basically. So the node number for each chapter increases monotonically. We just start counting up 1, 2, 3, et cetera, et cetera. And so we need to make sure that we keep track of what's the next node that we are going to write. And then we have our rewrite and continue instructions, which are passed in by the user when they give the graph instructions on what to do, whether they want to rewrite or continue. And then we also have our overall story title. So this is the state for our story, and this is our overall graph state. So now let's look a little bit at what this chapter graph actually means and what these children, sibling, and cousin and parent attributes represent. Okay, so this is the same graph that we saw at the beginning, except this time we're going to pretend that the user is currently viewing node 5. So node 5 is highlighted in red. And when a user is at a node, we're going to give them some options. We're going to give them the option to go back a chapter, to go forward a chapter, or to stay at their current chapter. For each of those choices, there's going to be different chapters they can select. So let's start with the going back a chapter, which is the simplest case. In going back a chapter, they're only going to be able to select the chapter that was their direct descendant. So in this case, node 4 is a direct descendant of node 5. It's the one that immediately precedes it. And so each node has one parent, and that's the only thing they can go back to. Now you'll notice for some nodes, like for instance node 7, the parent node doesn't appear immediately obvious. The way you find the parent node for something like node 7 is we're just going to traverse backwards on these black lines until we reach a prior chapter. So in this case, we'll go from node 7 to node 5, and then from node 5 to node 4. So node 4 will be the parent for node 7 as well. Okay, so there's only one option if you want to go back a chapter. What if you want to stay at the same chapter? So if we want to choose a different version of the current chapter. So you can always choose yourself. You can always stay at node 5. And then you can also choose something we call siblings. Siblings are chapters that are created by clicking the edit button. So in this case, the only sibling is node 7, but you could imagine clicking the edit button 2 times, 3 times, 20 times, however many times you want. And all of those nodes that you generate by clicking the edit button and the edit button only would be siblings of node 5. So if node 7, if you clicked edit again, or edit again and edit again, you'd create all these yellow nodes, and they would all be directly related to node 5 as siblings because you clicked the edit button to get to them. And then we have something called cousins. Again, I'm going to apologize for the terminology. It's not super clear, and this decision was completely arbitrary. I encourage you to design the graph as you wish and design it to the specifications that you want. But in our example, we define cousins to be continuations from the parent. So they're different continuations from its parent. So node 5's parent is node 4, and we can see that node 6 is a different continuation of the story from that point. So we were at node 4, and we created a new version of the next chapter, which in this case is chapter 3. So we clicked continue and we created node 6, which is a different version than node 5. If we had clicked continue again and we created another yellow node and another yellow node, however many we want, those would all be cousins to node 5 because they all originated from the same place, even though they're not directly related on this chapter graph. So if you're at node 5, you can select either node 6 or 7 to switch to as the current chapter. And now that we've discussed the previous and current chapter options, let's move on to the next chapter options, which are actually fairly straightforward. For the next chapter, you can select any of your children. So this is really simple. Any of the nodes that you clicked continue to generate are your children. So in this case, there's only one node that was generated, but you can generate a lot of different nodes by clicking continue. If you don't like the route that the LLM graph took, you can just click continue again and provide it with different instructions in your continue instructions box. And that will create more children, and you can select any of the children to move to as the next chapter. So this is the basic definition of how we allow the user to traverse our chapter graph. Again, these definitions are arbitrary. You could let the user see any and all of the chapters to move to. You could let the user only see the parent and children. You could define different relationships. You can do whatever you want. This was just the way that we traversed, and if you want this to be very clear, make sure you read over the source code and understand everything as well as you can. But now that we've finished describing the state of the graph, let's go compile it, and then we'll look into how we can host it using LangGraph Cloud. Okay, this last cell is the finalization of our graph, and it defines all of our nodes and edges, which are really straightforward. We just have a conditional entry point called router, which decides which node we are going to use. And so it's a very simple logic. We check if there are any chapters written. If there are no chapters written, we're going to write the first one. If there are rewrite instructions, we're going to edit, and otherwise we're going to continue. And each of these nodes lead directly to the end. So the only logic that is being done is in this router function. And then at the end, we are going to compile our graph into a variable called graph. So that is it for the definition of our graph. Now let's look into how we can host this using LangGraph Cloud. Okay, so we've put all of the code that we just wrote into a file called agent.py, and we've put everything under this story writing folder you can see here on the left-hand side. And the important thing that we've defined in the story writing folder is this langgraph.json file, which tells LangGraph how to compile our graph. So there are a few things that we have to put in here. First, we have to put the dependencies. So it's going to look for a requirements.txt file in the directory that we pass. In this case, we only have one directory with requirements, and we have the requirements from our imports at the top of our file. Then we have to pass the actual graphs that we want to be hosted. So this is a dictionary with the name of the graph and then the location of the graph. So in this case, we're only hosting one graph, but you can host as many graphs as you wish. All you have to do is make sure you have unique names and that you actually point the names to a compiled graph. So in our case, we are in the file agent.py and we're looking for the variable graph. And if you go to our file, at the bottom, you can see we have this variable graph that is equal to a compiled graph. So just make sure that any of the graphs you wish to host are pointed to with compiled graphs. And then this is for local development. You can pass an environment, but when we host on LangGraph Cloud, as you'll see in 1 second, we can actually add our environment variables in ourselves. One last thing before we go to LangGraph Cloud is that make sure to check out the LangGraph docs. We have Cloud docs, they're in beta, but they provide information on how you can test your graph locally using a few of our CLI commands just to ensure that your graph is running properly before you go host it on LangGraph Cloud. We've already done that testing here locally, so we're going to move straight on to hosting it on LangGraph Cloud, but make sure that you test before you go to hosting it because you don't want there to be issues once it's deployed in the cloud. All right, let's head over to LangGraph Cloud and see how we can deploy this. Okay, Now we are on Langsmith, and let's see how we can deploy our project. So we're going to want to go to the left-hand side navigation and click on this rocket ship called Deployments. And then we're going to go to the right-hand side and click this button called New Deployment. So the first thing you're going to want to do is connect your GitHub account right here in the left. You can see it's already connected to mine, but if you haven't, make sure you follow the instructions to do that. Then we're going to select a repo. So in this case, we're going to select the story writing repo. And we are going to also specify where our langgraph.json file is. In our case, it's in the root directory. We don't need to change this. But if your file is named something different or is located somewhere different, make sure you specify that here. And then you can also select the branch that you want to use. Since this is an example, we'll just keep it at main. But if you have different development branches that you want to deploy, make sure you specify the right thing here. And then we can select whether we want to have a development or production deployment. In this case, we're going to do development because we don't need a lot of servers. And then we can add any of our API keys. So in our case, we're going to need an OpenAI API key. And then we're also going to need an Anthropic API key. Of course, make sure to fill these values in with whatever the actual values of your API keys are. And then once you've set all of this up, if you want to edit the name, you can do that as well. Once you've set all of this up, click the submit button, and then we are going to end up with a deployment. Okay, wonderful. If I had clicked submit, I would have a deployment right here in this revision history. We would only have one revision since the initial submit, it would be here. You can look at this deployment to inspect the build and the deploy logs. You can see that this one deployed successfully. If you have issues with deployment, make sure to check out the docs and check out your graph definition to ensure that there are no errors. And then we're going to get this nice dashboard. So we are going to have information on all of our traces. There are more charts that we can access if we click this All Charts button. And then down here, we're going to see our specific traces. So I've already run a few traces on this story writing example, but once we use the front end, we'll see a few more traces show up there. And then you can also click on the API docs here to look at all of the different API calls that you can make. And please check out the LangGraph docs if you want to see more detailed explanations, and also if you want to see how the SDK correlates to all of these API calls, because using the SDK is really nice, and we'll show how to do that when we walk through the front end really quickly. And then the last thing you can do is use the playground. Okay, and then when you get to the playground, you're going to see this nice interactive graph, which you can move around. We can also put in input here. So we can run threads, and while this is running, you'll see on the left-hand side, the graph actually highlights what nodes are currently running. And then I'll walk through a couple more of the nice things of the playground. On this left-hand side right here, this dropdown, you can select the graph you want to use. So in our case, we only hosted one graph. Remember, in the langgraph.json file, you can declare as many graphs that you want to host as you wish. On this interrupts dropdown, we can select nodes to stop execution after, so we can dive deeper into the outputs, the intermediary outputs of our graph, and we can locate where errors are occurring. We can also toggle between the different threads that we have and go look at all of those here on the right-hand side. And then the last cool thing is we can actually make edits to our previous prompts. We can put in new information, and then we can fork the graph to run the story in a different way. So now we can see the graph is writing a serious story. So we're not going to wait for this to run, but this is just a quick walkthrough of how you can use the playground and why the LangGraph Cloud UI is so valuable for developers looking to debug and figure out what's going on with their graph. So now that we've ran through this, let's go look at creating the front end, and we will see how we can actually utilize our app. All right, let's look a little bit at our front end now. We're not going to dive into all of the Streamlit code that we've written here. If you want to, you can look at the repo and follow along yourself. But for now, we're just going to look at some of the utilities of the LangGraph Cloud SDK and how it makes writing our front end easier. So the first thing we're going to do is we're going to create our agent. And so we're going to do that by getting our client, setting an assistant and a thread. And for getting our client, we just need to pass the URL of our deployment. You can also pass in the API key if you want. In our case, I have the API key saved in my environment, and so I know it will find it, and I'm not going to pass it in as a parameter, but you can do whatever's easiest for you. And then one other thing to notice is we're going to pass some metadata to our threads, because all of the people who use this website are going to be accessing the same client, but we want to make sure that they're each creating threads that are unique to them. So in this case, we're going to pass some metadata with a session ID. In our example, we just create a random string for the session ID, but you could create some login information or get an IP address or something so that this information persists across several browser sessions. Now let's look at how the load stories works. So when a user clicks on load stories, we're going to call this function called getUserThreads, which searches all of the threads using the same metadata. So we're only going to find threads, and remember, threads correspond to stories. We're only going to find threads that this user wrote themselves. If we didn't filter on this metadata, we would return all of the threads that were in this client. And so if you have 10 people using the app, you would be able to see stories from all 10 of those people. And so that's obviously not something we want. And then for each of those threads, we're going to get that thread state. So we're going to actually get the state for each of those threads to find the story title. And then we will return those story titles to the user so that they can select a story to switch to. Now let's look at the most important function in our front end, which is the generateAnswer function. And so this function is the function that streams back the response to the user, and it works fairly simply. All we have to do is call client.runs.stream, and we are going to pass in our thread ID, our assistant ID, the input that we want, any metadata that we pass to the config, and then we're going to also set the stream mode to be messages. If you want to learn more about the different stream modes, make sure to check out the docs. I'm not going to dive into that now. And then we're going to also set our multitask strategy to rollback to deal with double texting, which is when a user enters an input before the first input has finished running through the graph. Again, check out the LangGraph docs to learn more. And then what we're going to do is we are going to use a little bit of logic to select whether we're streaming back the data or not. So if the LLM is the right LLM, and that's, again, if you remember our walkthrough of the backend code, that's the LLM that's actually writing the text for the chapter. What we're going to do is call this placeholder.info function, and this is a Streamlit function that's going to allow us to stream text as it arrives. And so that's, if you remember when we looked at the UI, we could see that blue box filling in as the chapter was written. If the LLM is not the right LLM, though, we still do something, which is this placeholder title code. And that's that little blue box that tells us whether we're in the brainstorming phase, whether we're in the planning phase, or whether we're in the writing phase. And that's going to use this LLM to title dictionary to provide the title that we should put in that little blue text box. And that's going to provide our user with some information. And again, if we didn't do any of this streaming, the user would have around 30 to 35 seconds before they would see any output, and so that can be really frustrating. So utilizing this streaming and utilizing different styles of streaming, again, we don't need to stream the text from all of the LLMs, we can select which LLMs to stream from, is really powerful and gives this a much snappier user experience. All right, now let's just check out one last thing, which is how our Langsmith traces get sent. And it's really simple. All we're going to do is create a feedback client, and we're going to pass our Langsmith URL here. In this case, I'm just using the development URL, but in your case, you'd most likely be using the normal Langsmith URL. And then when somebody presses one of these bad writing or good writing buttons, you can see these are pretty much identical code. What we're going to do is we're going to find the run ID that's corresponding to the current node ID. So that's the run ID of the current node that we are viewing. So again, the user can be changing between a bunch of different chapters, and we want to make sure we send feedback to the right run. So we're going to call this function called getRunID corresponding to node. And up here, this is again going to be utilizing the LangGraph Cloud SDK, and it's really great. We can list all of our runs with the correct thread ID, and then we can find the run that corresponds to our node ID. We'll return that run ID, and then back here, Once we've found that run ID, we can create feedback on our feedback client, and we will give it a score of 0 if they press the bad button and a score of 1 if they press the good button. So this is a super easy way of sending feedback automatically to LangSmith. And this is a really simple example, but you can imagine sending more detailed feedback such as text feedback, different scores for different parts of the writing, etc., etc. If you want to learn more about all of the front-end code, be sure to check out the repo and look at it in depth. Okay, now we're just going to do a very brief walkthrough of our front end. I'll let you interact with the front end on your own if you wish by using the website link in the description. But right here we can see we're in the middle of a story called Masquerade of Intrigue, but we're going to start a new story and we're going to provide some very basic details and we are then going to click submit, and we're going to start seeing our responses streamed back to us. So currently the graph is brainstorming ideas for the chapter. And after it brainstorms, as you can recall, it's going to start planning the outline. And then once it's finished planning the outline, we're going to see the story actually get streamed back to us. And once the story is done getting streamed back to us, it's going to generate a title for the overall story as well as a title for this first chapter. So we have a new story called Mule Mayhem, and the first chapter is called Betsy's Gambit, Hank's Wild Ride. And we can scroll through to read the chapter. And then if we wanted to edit this chapter or continue the story, we could click on this edit or continue buttons. I'm not going to walk through those right now because it's a very similar writing process to the new story button, but please go use the app yourself and interact and test out those functionalities. I am going to show how we can propagate feedback to LangSmith, so I'm going to click on the good writing button here, and then in 1 second we'll go over to LangSmith and see how that shows up as feedback on our trace. And then I'll also show this load story functionality, which lets us load stories that we'd written previously. So we can see we switched from Mule Mayhem to Masquerade of Intrigue, and we can switch back if we like. So this is a really cool thing about LangGraph is that it keeps our threads, so we can always go back to previous threads and load the state from those threads just as it was. So now let's head over to LangSmith to see how that writing feedback got propagated. Okay, now I'm on LangSmith, and I'm going to look at that trace I just sent. We can see that funny story based in California with a writing style of Mark Twain, which is what I just inputted. We can see on the left-hand side the typical LangSmith trace layout. So if you're familiar with LangSmith, this should look really similar. And then let's look at the feedback tag, and we can see that we've created this feedback with a score of 1 by clicking the good writing button. So the bad writing represents a score of 0, and the good writing represents a score of 1. This is a really simple feedback key, but you can generate whatever feedback you want. You could have text feedback, you can have numerical feedback, you can do whatever you like. And this allows you to sort through your traces, find traces with bad feedback, and you could use those as few-shot examples to improve the performance of your model. Or you can go into the playground and dive deeper into those threads and see exactly what was going on under the hood. But just a super nice thing about LangGraph Cloud is that it lets us send feedback automatically from the user to our backend in LangSmith. So I hope you've enjoyed this quick walkthrough of the story writing app, and I hope you have been inspired to write your own LangGraph Cloud applications, and I can't wait to see what everyone builds. Have fun using LangGraph and the new LangGraph Cloud. I hope you have a great rest of your day.